Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Today we have last lecture of marine boilers and will start the study of marine auxiliary systems and deck machinery from the next lecture. Today we have 30th lecture and the topic is boiler accessories. First of all, we will learn about the soot blowers which are used to keep the heat transfer surfaces clear of the soot in large oil-fired boilers and in forced circulation exhaust gas boilers used on motor ships. We will then learn about the use of reducing valves in steam pipes with their construction and working principle. Lastly, we will learn about the steam traps used with steam heaters for utilizing the latent heat of steam through the following slides. Soot blowers. Soot blowers are generally required in large capacity water tube boilers on the steamships or forced circulation exhaust gas economizer on motor ships. Purpose of soot blower. Their main purpose is to maintain the heating surfaces on the gas side of a boiler in clean condition and prevent heavy buildup of deposits which can lead to corrosion and uptake fires, in addition to drop in boiler efficiency due to poor heat transfer. Medium used for blowing soot. Steam is the usual medium for blowing off the soot from heat transfer surfaces on steamships. Although some motor ships use compressed air for this purpose. Soot blowing by compressed air at 30 bar pressure provides better result than steam at 9 bar and requires much less soot blowing operations in comparison to steam. Condition of steam. Steam used for blowing the soot should be superheated so that the boiler tubes are not affected by erosion caused by the water droplets contained in the steam. Steam pressure on motor ships is low and at the same time it is not superheated, which can affect the bare tubes of exhaust gas economizer. Present day forced circulation exhaust gas boilers have gills shrunk on to the tubes, thus protecting them from erosion and corrosion. Working principle of soot blower. Pressure energy of the soot blowing medium is converted into the kinetic energy which is passed through the nozzle which is used to blow up the soot. Manually operated soot blower. The sketch shows a manually operated soot blower used on earlier ships. Soot blower consists of three main parts, that is steam chest, operating mechanism and head assembly. Steam chest is formed by the gooseneck. Steam is supplied by the inlet valve. Soot blower tube is connected through gland packing, which prevents the leakage of steam. Operating mechanism consists of chain wheel rotated by an endless chain and drive the pinion. Pinion drives the main gear to which is attached a cam for operating the spring-loaded valve. Head assembly consists of heat-resistant steel tube to which one or more nozzles are attached. Air connections are provided for cooling the soot blower and sealing for preventing the deposition of soot. The soot blower also consists of manually operated steam inlet and drain valves. After the completion of soot blowing cycle, drain valve is left open until next cycle. Retractable type soot blower. This sketch shows a retractable soot blower mounted on boiler's outer casing, which is operated by electrical motor through a reduction gear and can be arranged to start and stop automatically. Such a soot blower is suitable for UMS ships. A timer is used to start the soot blower, which stops automatically after the completion of one cycle. When an electric motor starts, it turns the operating screw through the gear drive. Rotation of operating screw moves the nozzle outwards in the furnace or heat exchanger. When cam reaches its end position, it pushes the valve operating mechanism and opens the shut-off valve to admit the superheated steam. Seal drains prevent the leakage of steam and facilitate the entry of steam in annular space through admission ports which coincide with the steam inlet. Cooling air is supplied to the tube wall box from forced draft fan in case of oil-fired boiler or from scavenged air in case of exhaust gas boiler. Apart from cooling, air also acts as seal to prevent the entry of exhaust gas and soot into the valve box. Electric motor is stopped in this position by the position switch and soot blowing process is continued. After the elapsed time, electric motor reverses, thus retracting the nozzle assembly in its housing. When it reaches the innermost position, a limit switch stops the electric motor, completing one cycle. Automatic operation is suitable for exhaust gas economizer during the sea passage. However, on conventional oil tankers boiler, manual operation is preferred during the cargo discharging as inert gas plant has an interlock with the operation of soot blower. To operate the soot blower manually, a handle can be fitted to the square provided at the end of the operating screw. Flexible coupling provides Independent manual and electric motor operation. While operating the soot blower manually, supply to the electric motor should be put off as a precaution to prevent injury. For same reason, handle should be removed after the use. Reducing valve. The sketch shows a reducing valve which is used for lowering the steam pressure as per requirement, such as maintaining steady heating steam pressure of 4.5 bar in spite of fluctuating auxiliary boiler pressure from 5 to 9 bar on motor ships. Reducing valve consists of disc connected with the diaphragm as shown. Valve is usually placed in inverted position to prevent the damage to diaphragm from high temperature of steam. The diaphragm is loaded by the spring whose force is adjusted by the screw. Steam enters the valve at pressure P1, which may have fluctuations but leaves out at pressure P2, which is almost steady. Inlet pressure P1 acts in the upward direction on the main valve and in the downward direction on the controlling flexible diaphragm. These two forces are in state of balance. Let us analyze the forces. Downward force is equal to P1 into capital A plus P2 into small a. Upward force is equal to P1 into small a plus F, where F is spring force. In equilibrium, downward force is equal to upward force. Therefore, P1 into capital A plus P2 into small a is equal to P1 into small a plus F. If P1, capital A and small a are constant, P2 varies directly as F. Reducing valve maintains the downward steam pressure within defined limits over a range of flow despite fluctuation in the supply pressure. Spring pushes the spindle tending to open the valve against the reduced steam pressure P2, acting on the area small a at the top of the valve. A decrease in pressure on the outlet side will allow the valve to be pushed open by the spring, whereas increase in the outlet pressure will close it, thus maintaining within the specified limits. In unmanned machinery space, self-regulating valve can be replaced by an automatic process control valve which permits remote control of the set point and variety of flow characteristics. Reducing valve arrangement. The picture shows a reducing valve arrangement used on the ships. Steam is admitted to the manifold through a strainer to protect reducing valve from a damage. Stop valves are provided before and after the reducing valve for its maintenance or repair. A bypass valve is provided for controlling the steam pressure manually should the reducing valve fail to control the steam pressure automatically. A relief valve is provided on the reduced pressure side to prevent the rupture of pipe if the reducing valve does not work properly. To monitor the pressures and adjustment of reducing valve, pressure gauges are provided on inlet and outlet sides. Steam trap. What is the steam trap? A steam trap is a special type of valve which prevents the passage of steam but allows condensate to pass through. Where is it used? It is used at the outlet of steam heater and works automatically to drain the condensate without passing any steam. What is the purpose of steam trap? The benefit gained with the steam trap is that the steam is contained in the heating coil until it condenses, thus giving up all its latent heat. What if the steam trap does not function? A faulty steam trap can cause reduced heat capacity of the heater. It is usually equipped with a bypass valve to control the flow of condensate manually. What are the types of steam traps? Steam traps may be float type, thermostatic or thermodynamic types, which are discussed through the following slides. Float type steam trap. The sketch shows a float type steam trap which tends to discharge the condensate proportionally to the rate of incoming condensate. It consists of a chamber containing a float and arm mechanism which modulates the position of discharge valve. Condensate enters from the top connection, and as the level of the condensate in the trap rises, the valve is open to discharge the condensate from the outlet. As the discharge valve is below the water line, it employs a venting system to discharge non-condensable gases through a thermostatic element which opens the valve when cooler non-condensable gases are present but closes the valve in the presence of hotter steam. Thermostatic type steam traps. The sketch shows a bellows type steam trap which uses the expansion of flexible bellows to open the valve. It consists of a flexible bellows B filled with a mixture which boils at a lower temperature than that of the steam and attached to the valve V. Condensate enters from the top and leaves from the bottom. When steam enters, it expands the bellows and closes the valve. The trap compensates itself for varying pressures. It will be damaged if water hammer occurs and will burst if subjected to superheated steam. Figure shows a bimetallic type steam trap which uses the expansion of bimetallic strip to close the valve. It consists of bimetallic strip attached to the valve through the spindle. Condensate enters from the bottom, passes to the strainer, flows around the spindle and finally leaves from the bottom. As the steam approaches bimetallic strips, their temperature increases and deflection of the bimetallic strip closes the valve. This type of steam trap can work over a wide range of pressures without the need for readjustment and can operate satisfactorily under superheat condition. It is not prone to damage by water hammer or vibration. Thermodynamic type steam trap. The sketch shows a thermodynamic type steam trap which uses the pressure energy of the steam to close the valve. It consists of a metallic disc which rests on the seat ring when the valve is closed. Condensate enters from A, passes through strainer S, lifts the metallic disc and leaves from B. It continues as long as condensate enters. As the steam approaches, condensate temperature rises and it flashes to steam. Steam pressure acting on top of the disc overcomes the static pressure underneath and starts closing the valve. This position shows a closed valve with steam pressure acting on top of the disc. To start the cycle again, an orifice is provided on the seat ring which reduces the dynamic pressure acting on the disc. If the condensate is present, it will get discharged, otherwise the valve closes again. In practice, the trap usually opens after every 15 to 25 seconds and the length of opening time depends on the amount of condensate to be discharged. If no condensate has been formed, then the trap snaps shut immediately. This completes the study of soot blower, reducing valve and steam traps. This book is written by me and covers all the topics as per Indian Maritime University syllabus. It is also recommended by the Indian Maritime University as a reference book. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the students in preparing for the exam and also to work on ship's boiler safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share with your friends. You may subscribe to the channel for getting notification about the new tutorials. I'll be back with a new lecture shortly. Thanks for watching. till the end.